How do archaeologists use SfM to build 3D models of artifacts? Imagine holding a tiny artifact in your hand and being able to see every detail from every angle as if it's right in front of you. That's what structure from motion, or SfM, makes possible for archaeologists. It's a clever way to turn photos into detailed three-dimensional models. First, archaeologists take lots of pictures of the artifact from different angles. They make sure each photo overlaps with the next by about 1/3 to 1/2. This overlap is important because it helps the software recognize the same features across multiple images. Usually, they use a digital camera, and they record the camera settings and position to keep track of how each photo was taken. Once they have all the photos, they import them into special software designed for photogrammetry. The software then searches for matching points across the images. These are often corners, edges, or unique marks on the artifact. By analyzing how these points shift between photos, the software calculates where the camera was for each shot and the three-dimensional position of each point. This process creates a rough outline called a sparse point cloud, which shows the general shape of the object. Next, the software adds more points to fill in the details, creating a dense point cloud. These points are then connected with tiny triangles to form a mesh, which is like a digital net that wraps around the object's shape. The final step involves projecting the original photos onto this mesh, adding color and texture to produce a realistic 3D model that looks just like the real artifact. This method is especially popular because it is non-invasive, meaning it doesn't harm the artifact. It's also relatively quick and produces highly accurate models. Archaeologists can use these 3D models for detailed analysis, sharing with other researchers, or even making physical copies through 3D printing. SfM has become a key digital tool for recording everything from small pottery shards and tools to large architectural features and entire excavation sites. It makes documentation faster, more precise, and accessible to everyone interested in archaeology.